Unsprung mass is important because it's a key part of the total evaluation and engineering and development for an automobile. It matters in how you do the ride and handling, which is a key part of how a vehicle behaves and how pleasant it is to drive. But the important thing is to know that as you add unsprung mass, you can engineer your way past it and actually recover those issues that are created with additional unsprung mass. It's really important to know that although we're 31 kilograms per motor, you think about it in terms of the horsepower we've added. In US numbers, it's over 100 horsepower. And then if you look at our torque, what we call torque density, or the amount of torque that you provide to the automobile, given the amount of weight that you've added, is really a pretty good ratio. It's a very powerful motor. So by adding some mass to the vehicle, you're also adding a tremendous amount of additional capability to the car. There was a study done by Lotus Engineering, and it was a very rigorous test done on a very difficult situation. And as they took a relatively small and lightweight car, and they took a traditional production Ford Focus, they evaluated it both in terms of objective measures, numerical measures, as well as subjective measures. Experts drove the car and rated it for ride and handling and its performance around corners and its performance over bumps. Then they took that same exact vehicle and modified it. They added mass to the vehicle, both to the front and also to the rear, where it was the static mass, in other words, the mass that's just added and stays there, as well as the rotational mass that would be added to the vehicle if you put the Protean motors on. Then they ran their tests again, and they found that there was a difference, but that difference could be recovered with traditional ride and handling techniques. They published a paper on it, and that paper is available on our website as well as in the public domain.